ELO ratings, while very powerful in chess or mixed martial arts or tennis, as a way to verify the quality of your opponent and to really go beyond just the schedule to see what is the true ability of one particular person against another person or one team in the NFL or NBA against another team. But in the case of coding, things start to fall apart a little bit. Let's go ahead and take a look at one of the ways that it could fall apart. So, in the case of AI agents, these are random users. Is the user a professional software engineer at Google? Are they a new student of computer science who just started taking programming courses? Are they a 10-year-old who has never even seen coding before? Who is this person, right? And so the fact that in the case of ELO, there are experts in a particular field that are playing against each other is very different than a random user. Also, what are the dimensions that we're measuring? Is it accuracy? Is it style? Is it speed? And so there's kind of this circular preference here where A beats B, and then B beats C, and then C beats A. But what is happening? There's all kinds of chaos here as well. And so there's some, I guess, unproven characteristics of ELO in terms of rating code. One of the things that could be interesting is if you looked at things, for example, in terms of cognitive bias. So, in the case of anchoring, for example, are you presuming that a particular model or a particular style or a particular language is better? Are you actually using confirmation bias? Is there also Dunning-Kruger effect? For example, we know that often people with low ability will rank themselves as having a higher ability, and the higher your ability, the more you're skeptical of your own skill. And this is the essence of potentially why ELO ratings could be a real problem. So one of the solutions could be, instead of just blindly doing the ELO rating, is to look at things from a quantitative perspective. We do know that there's a lot of computer science research around things like complexity. So if the complexity is under 20, for example, or the test coverage is above 80%, or there's no self-admitted technical debt, or, for example, the runtime of the algorithm, it's the big O notation is lower for one approach than another approach. There are ways to quantitatively measure the quality of code, and this is not happening in the ELO ratings. And this would be a very interesting way to supplement what's happening with ELO ratings, is to focus only on the quantitative components or mix the quantitative components with ELO. So it does raise some interesting questions about whether, in fact, ELO ratings for ranking agents is actually as good as it seems it is. It seems like putting traditional computer science metrics, and I mean, the dream scenario would be if you had, for example, the best software engineers in the world all looking at the different code examples, and it was annotated with the true metrics of the code. That would be a much different scenario than the current scenario we have with ELO.